Hey everybody, Justin here, 9 pound hammer, 5180. I tell you, man, I was eating me a little bit of dessert, and I got to thinking what ago, we're always talking about amplitude modulation. We're always talking about, excuse me, sideband, suppressed carrier. Um, Sometimes we're talking about single sideband, which is where we null a carrier and completely filter off one of the others and then use the information by putting the information, use the signal by putting the information on the sideband. Therefore, the transmitter is not having to produce energy to make the carrier. But guys, not very often do we talk about frequency modulation, and then actually show the characteristics of how frequency modulation uses more bandwidth, more space, uh, uh, how it uses continuous output. And whenever you're modulating on FM, you're modulating the frequency. So when you talk, you're using space instead of making growth at the carrier of the amplitude of the frequency. So we want to show you, we'll show you it several different ways. I'll tell you what, first we're going to come up here and show you it at 10K. So that's going to show it pretty tight. Anyways, let me roll up a decent little FM signal here. So as you can see, let me get a throw a tone into play. So there's an FM carrier, as you can see. Let me go. Let's simplify this quick that way, because we don't want to make a long video. So now, I'm going to pay close attention to this picture here. This is an FM signal. Now, you technicians out there understand that I'm injecting the input of the microphone. We're not direct inputting the transmitter, so that's why you're catching the transition of voice ratio into as I talk, because I'm inducting the microphone with my voice as well as the tone. So there's what FM, guys, looks like at about 14 watts output. Now, I want to keep the tone and everything on. I'm not even going to turn it off. I'm just going to go over here and turn the transmitter on AM. Now you're going to see the induction of my voice because I'm live and I'm live mic'd. Pay attention of how much space is being used. Look at the sidebands as the information comes up right there. Here it comes. And the signals on the left and right side of the carrier come up in growth. Here they come. See them? That's the information, guys. That's the voice and what you hear on your end. See the signal in the very center? That's your carrier. And the two signals to the left or right are your sidebands. The information as I talk is being, see where it is being modulated off the carrier, left and right. Notice how much space it's taking up. Let it cool down just a second, and we're going to go right to FM. never changing anything. Pay attention. Now look at the amount of space. Notice how it's taking the entire screen. So that's a demonstration of how FM uses more space. Here's an AM signal without tone. First, we'll go back to the FM signal without tone. Once again, guys, this is without tone. Pay attention to the FM carrier. Pay attention to the occupied space that it's using. Remember how you count this, guys. We're looking at 2 per division, so you're counting off the, here's the center. So we're looking 4 kilohertz. Each side of center. Look at it. Look at that occupation of bandwidth versus this AM signal. Notice how much narrower and littler of occupation that the AM carrier is taking. This stuff that, when you're looking at AM, the stuff that's down here rolled off way, way down, that's not what we're looking at. But when we go to FM, you're going to notice that even up here in reference, look how much wider it's occupied. Now we're going to go back to AM. Now we're going to go right back to FM. Where I want y'all to look at's right here. Look right in here. AM. The 2 sidebands, lower and upper sideband. When we go to FM, they come play way over here on your frequency. Check it out. Look how much. Look what. How much occupation. So the signal comes from right here and goes all the way out 8K, 4 each side. Remember, center frequency, and this is the divisions that you have set in frequency. When you're looking at the spectrum, guys, we're looking at frequency. Amplitude of the frequency over. When we're looking at the scope, it's voltage over time. We're taking a measurement over a certain amount of time and continuing to cycle that measurement, and then measuring the differences of that measurement, all doing it so fast to where on the spectrum side, which is the white, it's measuring it over frequency. So when you're on FM and you're talking, your signal is growing this way, guys, not this way. In AM, we want our signal to grow this way, but in FM, we want to occupy this way. That's why when we're on FM, if somebody's on FM and say you're talking to somebody on AM and you get somebody that's got 2 or 3 watts on FM, and you're running 25 on AM, they completely blast the band. It's because you're using 2.6, 2.8 kilohertz of bandwidth on the AM, and the FM signal is completely occupying all of that. 7 threes from 9 Pound Hammer.